Today we're going to talk about the unit circle. In the last section, we learned a little bit about radian measure and how it compares to the measure of degrees that's a little bit more familiar for us. Well, let's, for today, start with a circle. Let's consider this circle with its center at the origin of a graph and its radius 1. So if it's at the center of this graph here, and it's got a radius of 1, it will definitely hit these 2 points on the x-axis and these 2 points on the y-axis. So all of these points together are 1, 0, and then 0, 1, negative 1, 0, and 0, negative 1. So from here, what I'm going to do is I'm going to take a number line and I'm going to put it vertical instead of horizontal like we normally see it, where the positive side is going up and the negative side is going down. And what we're going to do is we're going to take this number line and we're just going to wrap it around the circle over and over and over. Because we learned about coterminal angles last time, we'll then know that as we wrap this around, it's going to wrap over itself, and each of those points, each of those numbers, is going to align with additional numbers that take up that same space. Now that's going to look something like this. Now another thing we also know is that a circle has a circumference, and that circumference is 2 pi r. Well, in this case, if the radius is 1, then the circumference is 2 pi times 1, or just 2 pi. Well, what we've done here is create something called the unit circle. And so I've still got these 4 points, 1, 0, 0, 1, negative 1, 0, and 0, negative 1, but I've identified a whole bunch of other points here as well. So in between 1, 0 and 0, 1 on this circle, we've got the point the square root of 3 over 2 and 1/2. So this point on the graph is the x value, square root of 3 over 2, and the y value, 1/2. This point on my circle and on my graph is square root of 2 over 2, square root of 2 over 2. So both the x and the y are square root of 2 over 2. And then we've got this point, 1/2, square root of 3 over 2. So the x value is 1/2 and the y value is square root of 3 over 2. So you can read the rest here, but there's going to be a lot of square root of 3 over 2s, a lot of square root of 2 over 2s, and 1/2s. Each of these points on this circle will create an angle to our initial side, which is going to be our positive x-axis. So when I look at this point here, square root of 3 over 2, 1/2, this creates a 30-degree angle. In radians, that's pi over 6. This point, square root of 2 over 2, square root of 2 over 2, creates a 45-degree angle. In radians, that's pi over 4. And this point, 1/2, square root of 3 over 2, is a 60-degree angle. Radian measure, that's pi over 3. Now, why this is useful is because I can actually use the points on the graph to determine what the cosine, sine, and tangent are of these angles. When I look at, say, pi over 6, if I want to find the cosine of pi over 6, then that's going to be the x value of this point. So the cosine of pi over 6, or the cosine of 30 degrees, if we're using degree measure, is the x value, so this is square root of 3 over 2. The cosine of pi over 6 is the square root of 3 over 2. If I want the sine of one of these, I look at the y value. So the sine of, let's say, 5 pi over 4. So let's find 5 pi over 4 right here. The sine is negative square root of 2 over 2, because that's what the y value here is. And tangent, this is sine over cosine, sine divided by cosine. Now you could find that by hand. What I've done is I've just written in what all of these tangents are. So the tangent of, say, 2 pi over 3. So find 2 pi over 3, that's right here. The tangent is negative square root of 3. And there are 6 basic trigonometric functions that we want to keep in mind. We just talked about 3 of them. cosine, sine, and tangent. Again, the cosine is going to be the x value. The sine is going to be the y value. Tangent is sine over cosine. To save you some time, I've written what these are. But we've also got cosecant, secant, and cotangent. Here's what these are all abbreviated to. So sine, we just take off the E, SIN. Cosine, COS. Tangent, we'll abbreviate that to TAN. Cosecant, this is CSC. Now the cosecant is the reciprocal of the sine. So if sine is the y value, then cosecant is 1 over y. Just take that, flip it upside down. Secant is abbreviated SEC, and this is the reciprocal of cosine. So if cosine is x, then flip this upside down. Secant is 1 over x. And cotangent, abbreviated COT, this is the reciprocal of the tangent. So if tangent is y over x or sine over cosine, then cotangent, flip that upside down. This is now cosine over sine. Now you'll see here that for 4 of these, y cannot be 0 here, x cannot be 0 here, x cannot be 0 here, y cannot be 0 here. Why is that? Because if we have 0 in the denominator, well, we'd be dividing by 0. That's not possible. So we get some things that are undefined. As an example, let's look back up here. We have a tangent of pi over 2 is undefined because remember the tangent is sine over cosine. So the sine would be 1, the cosine is 0. 1 divided by 0, I can't divide by 0, so this is undefined. Same thing for 3 pi over 2 or 270 degrees. If I try to find the tangent of this, this would be negative 1 divided by 0. Can't do that, so that's undefined. So let's do some examples. Let's evaluate the 6 trigonometric functions for the real number t equals pi over 6. So I want to find the sine, cosine, tangent, and then after I find those, we're going to flip those upside down, find the cosecant, the secant, and the cotangent. The very first thing I need to do, though, is look at my unit circle and identify where pi over 6 is. So let's bring that up right here. And I want to find pi over 6. So that's right here. That says the x value is square root of 3 over 2. So in other words, the cosine of this is square root of 3 over 2. The y value is 1/2. Okay, so that's going to be the sine. And then the tangent is what's out here. This is sine over cosine. This is square root of 3 over 3. Excellent. So I'm going to write those down for the cosine, the sine, and the tangent. Let's see, we said the sine is 1/2. The cosine was square root of 3 over 2. And the tangent is square root of 3 over 3. Okay, so then the sine of pi over 6 is 1/2. Cosine is pi over 6 is square root of 3 over 2. The tangent of pi over 6 is square root of 3 over 3. To find the cosecant, secant, and cotangent, we're going to do the reciprocals of sine, cosine, and tangent, respectively. So cosecant. If this is 1/2, if the sine is 1/2, then the cosecant is going to be 2 over 1, or in other words, just 2. The secant. If the cosine is square root of 3 over 2, I'm going to flip that upside down, and I'm going to have 2 over the square root of 3. Except I don't really like this answer because I've got the square root of 3 in the denominator. So I want to rationalize the denominator. That means let's multiply the numerator and the denominator by this square root of 3. Okay, so the top part, 2 square root of 3, just going to leave that alone, over the square root of 3 times the square root of 3. So this is the same as saying the square root of 3 squared, square root of 3 squared. So the square root and the squared, those are going to undo each other, leaving just 3. the secant of pi over 6 is 2 square root of 3 over 3. And the cotangent. So if the tangent is the square root of 3 over 3, then the cotangent is going to be, let's find the reciprocal, 3 over the square root of 3. Now, same thing as secant. I don't really like this square root of 3 in the bottom here, so let's rationalize the denominator. Let's multiply by square root of 3 over square root of 3. All right, 3 square root of 3 on top. And the square root of 3 times square root of 3, so square root of 3 squared, will leave 3. Now this one's going to be a little different because I have a 3 on the top here multiplied to the square root of 3, and I've got a 3 on the bottom. So I can actually divide these out. And the cotangent of pi over 6 will be the square root of 3. All right, what about 5 pi over 4? Find the sine, cosine, tangent, cosecant, secant, cotangent of 5 pi over 4. So again, first thing I want to do, bring up my unit circle, and let's find 5 pi over 4. So 5 pi over 4 is right here. Okay, so 5 pi over 4, the point here is negative square root of 2 over 2, negative square root of 2 over 2, and the tangent is 1. Okay, so cosine and sine are the same. They're both negative square root of 2 over 2. Tangent is what's on the outside. That is 1. Let's write those down. Negative square root of 2 over 2, negative square root of 2 over 2, and 1. All right, cosecant, secant, and cotangent. These are going to be the reciprocals, again, of sine, cosine, and tangent, respectively. So let's begin with the sine. So sine is negative square root of 2 over 2. That means the cosecant is going to be, flip this upside down, negative 2 over the square root of 2. Again, let's rationalize the denominator. So I'm going to multiply the top and the bottom by this square root of 2. This will get me negative 2 square root of 2 over square root of 2 squared is 2. And I can divide those out to get negative square root of 2. All right, secant. Well, hold on a second. If the sine and the cosine are the same, oh, this should be a 2 here. If the sine and the cosine are the same, and I just found the reciprocal of the sine to get the cosecant, then I don't need to go through all that work again. I know that this is also going to be negative square root of 2. And lastly, the cotangent. Well, this tangent I can think of as 1 over 1, because that's 1. So if this is 1 over 1, when I flip that upside down, it's still going to be 1 over 1. So just 1. All right, one more of these. What about for pi? So let's grab our unit circle. Let's find where pi is. That's right here. Okay, so pi has the point negative 1, 0, and then outside I've got 0. So this means the cosine is negative 1, the sine is 0, and the tangent is 0. All right, so I've got 0 here for the sine, negative 1 for cosine, and again, 0 for tangent. Now, cosecant, secant, cotangent. This 0 here for the sine, I can think of this like 0 over 1 if I wanted to. Well, if I flip that upside down, the cosecant would be 1 over 0, but I know that I can't ever divide by 0. So then this is undefined. We can say the same thing for the cotangent. If the tangent is 0, then the cotangent is undefined. And for the secant, well, the cosine is negative 1. Think of that as negative 1 over 1. Flip that upside down, it's still negative 1 over 1, so the secant is negative 1. Okay, so that is a lot of what we'll be doing with the unit circle. Is I'm going to ask you, what's the sine of this? What's the cosine of this? What's the tangent of this? Or I might get a little tricky and I might say, what's the secant of this? What's the cosecant of this? What's the cotangent of this? And you're going to use your unit circle to find those things. But sometimes you're also going to get things that are not on your unit circle. Remember that these trig functions are periodic, which means that they cycle back around. As a circle, this means that things will go around the entire circle and then go maybe even a little bit more, and it'll land on a spot that might correspond with another spot that's just one of the cycles through this circle. On a graph, this means that as you're graphing, say, the sine or the cosine function, it's going to go up and then back down and then back up. It's going to return to its starting position. Now, the sine and the cosine functions, we're going to look at those graphs at another time. They are continuous, whereas these other trig functions are not. And we'll find out what that means in a later section. The sine, cosine, cosecant, and secant functions have a period of 2 pi, and the tangent and cotangent functions have a period of pi. So let's take a look at this here. It says evaluate the sine of 13 pi over 6. Well, if I look at my circle here, 13 pi over 6 doesn't exist. Okay, I've got like 11 pi over 6, and if I add another pi over 6, technically that'll bring me to 12 pi over 6, which is back to 0. So 13 pi over 6 is actually greater than 1 full revolution around this circle. It means that I'm going 1 full circle and then a little bit more. So what I can do is, since I know that I'm going more than this 1 circle, I can just subtract that 1 circle. In other words, I want to subtract 2 pi. It's 2 pi all the way around the circle. So let's find 13 pi over 6 minus 2 pi. Well, I can't quite subtract these as it is. This is 13 over 6, and this is not the same denominator. This is 2 pi over 1. But I can rewrite this. 2 pi is the same as 12 pi over 6. Because 12 over 6 is 2. So if I think of this as 13 pi over 6 minus 12 pi over 6, then I get pi over 6. In other words, the sine of 13 pi over 6 is the same as asking, what is the sine of pi over 6? Well, that I can find, because on my unit circle, I do have pi over 6, and the sine is 1/2. Therefore, the sine of 13 pi over 6 is also 1/2. Next one, evaluate the cosine of negative 7 pi over 2. All right, well, clearly, negative 7 pi over 2, I'm not going to find that on my circle because none of these are negative. So that means that I can just keep adding full circle. I can keep adding a full 2 pi, or in this case, since the denominator is 2, I can add 4 pi over 2. 4 over 2 is 2, until I find something that's on this circle. So let's begin with negative 7 pi over 2, and I'm going to add 2 pi, but I'm going to write it as 4 pi over 2. And negative 7 plus 4 is negative 3. So this is negative 3 pi over 2. Not quite on the circle yet. So what I'm going to do is take this negative 3 pi over 2, and let's just add another circle. Let's add another 4 pi over 2. Negative 3 pi over 2 plus 4 pi over 2. Well, that's going to be positive 1 pi over 2 or just pi over 2. So this negative 7 pi over 2 is the same as pi over 2. Therefore, cosine of negative 7 pi over 2 is the same as asking what is the cosine of just a single positive pi over 2. Now I can go back to my circle, find where pi over 2 is. That's right here. And the cosine is 0. All right, last thing to talk about. Even and odd functions. There are 6 basic trig functions that we just talked about. Cosine, sine, tangent. We've got the secant, cosecant, cotangent. There are only 2 of these that are even functions. The cosine and the secant, these are even functions. And then odd functions, sine, cosecant, tangent, cotangent. What does that mean? Well, an even function, when you plug in something for x, you will get the same result as if you plugged in negative x. And an odd function, if you plug in, say, that negative x, it's the same as if you plugged in x, but then made whatever your answer is negative or opposite of whatever it is. What do I mean by that? Well, let's take a calculator out and let's try something. Let's plug in the cosine of, well, make something up, 3 pi over 7. So the cosine of 3 pi over 7. This is roughly 0.2225. Okay, well, what if I plugged in not cosine of 3 pi over 7, but let's do negative 3 pi over 7. So see here, if x is 3 pi over 7, then negative x is negative 3 pi over 7. I'm going to hit enter here, and we get the exact same thing. So even functions, whether you plug in x or whatever it is, or negative x or negative whatever it is you're plugging it in, you're going to get the exact same thing back in your calculator. However, odd functions, such as first one here is the sine of x. Watch what happens when I do sine of, let's plug in something else. Let's do 5 pi over 11. Okay, so sine of 5 pi over 11 is 0.9898. All right, let's try now sine of negative 5 pi over 11. With cosine, whether we plugged in something or that negative something, we got the same answer. However, with sine, I'm plugging in 5 pi over 11, and now I'm plugging in negative 5 pi over 11. It's the same thing, but now it's negative 0.9898. So that's what I mean by if you plug in, say, negative x, you get negative sine of x. What you would have gotten if you just plugged in positive x, but this whole thing becomes negative. Hopefully that gives you some insight as to how we're going to be using the unit circle, as well as just a little bit of information about our trig functions and when a trig function is even versus when a trig function is odd.